So today we will be creating this beautiful shiny mirror, and without further ado, let's get started. Alright, so let's start by creating a new scene. It can be a static body 3D, we can call it mirror. We're gonna add a mesh to it, which is gonna be our mesh. So let's just make it a plane, gonna make it 8x4, and then I'm gonna rotate it so that it faces the negative z-axis, which is our forward-looking axis. Let's also add a collision, so we cannot walk through it, and that can be a box, which is also gonna be 8x4, and it can be quite thin, so let's say 0.2. We can save this as a mirror, and we need a couple of more things. So we will need a camera that will capture our reflection, and to do that we first have to add a SubViewport, and SubViewport will capture whatever camera is nested inside it. So you'll see that if I add a camera 3D, this image fills up. So that's what our camera is seeing. And for helping purposes, I like to add a mesh to my camera, because it's easier to visualize what we are doing once we start playing the game. So let's just add a cylinder. I'll make it a bit smaller. Actually, let's do 0 and 0.25. Just gonna move it out a bit and rotate it. So this cylinder is gonna represent our camera. So I'll just move it back to the center. And one more thing that will be helpful is if we add a canvas layer and put a texture rect on it. This is going to render whatever our camera is capturing onto our viewports. So I'm just gonna position it here on the top left, and I will demonstrate that for you. So if we drag our mirror into the scene and we rotate it by 180 degrees, there we have our mirror. And if I press play, we see nothing. Well, that's because I haven't actually told this texture what it has to be. So if I select a viewport texture and select our SubViewports, save it and press play again. So now we see the world, and the top left you can see the camera's image. And you might be wondering, why are we not seeing the character from the front if the camera is inside the mirror? Well, the reason is that the SubViewport is not actually something that exists in 3D world. So this camera, which is attached to it, when it spawns, it doesn't know where to spawn. So it just renders at the world origin. And to prove that to you, if I start my game and I select this from local to remote, open our mirror, open our SubViewport and select the camera, you'll see, well, it's under the ground, but if I zoom in, you can see it's right here at the world origin. So let's talk a bit about how we want to position our camera. So let's say we have a mirror here and we have our player here, and we are looking at the mirror. So our camera is hitting the mirror, it's being reflected, and we want to project back to our camera whatever the reflection is from the other side. Now, where do we position the mirror's camera? Well, we have to position it on the opposite side of the mirror. So if we extend this line, like so, this is where our new camera position has to be. So what's the easiest way to get this location? Well, if we take our global position of our player's camera, we can transform it into the local mirror's space. And that means the X, Y, and Z's are gonna be located from the mirror's origin. So then if we take the X and Z, we can just flip the Z value over. And keeping the same X, we get this new position, which we can then convert back to global space. So let's do that first. Let's start by adding a script to our mirror. We can just call it mirror. And then we wanna get a hold of our player, which is type player. Then we wanna grab our SubViewports. I'm just gonna call it viewports. And it is of type SubViewports. And then we also want to get a hold of our camera, which is a camera 3D, and it is nested in the SubViewports, like so. And now, since we will be using information from our player's camera quite often, we can declare a variable for that called player camera, and it's going to be a camera 3D. So once the node is ready, we want to copy a few things from our main viewports to our SubViewports. And that's mainly the size and any possible anti-aliasing that we have. And that's just to make sure that the image from the reflection matches the image from our main game. So we can say main viewport is equal to get viewports. And then viewport.size, that's our SubViewport, is going to match the main viewport's size. And then we also want to match the MSA 3D, and same for screen space and temporal anti-aliasing. Then we also want to copy the camera settings from our player camera. So let's assign the player camera to player.getCamera. And getCamera is just a function in my player that returns a camera. So nothing special here. And then we want to say that our own camera.FOV is equal to player camera's FOV. And a few other things just to make sure that both of our cameras are also matching. Now that we have the viewport and the cameras set up, we need to set up a material for our mirror. So let's create a new shader, and we can call it mirror shader. And it's going to be a spatial shader, and we're not going to be doing anything with lights, and we're not going to be manipulating our vertices. It's just a spatial shader, and we can say render mode is going to be unshaded. So that way we get a crystal clear mirror. Now, we want to set our albedo. So we want to set the color of our material to be the camera's captured image. And to do that, we need to pass in that texture to our shader. And we can do that by saying uniform sampler 2D, and we're going to call this mirror texture, and it's going to be source color. And then in fragment, we want to say albedo is equal to texture. So paste our mirror texture and use the object's UVs. Let's rename this instance to mirror mesh just to make it easier to understand what's going on. And then we want to create a new material. So let's call it mirror material, and it's going to be shader material dot new. And then to that material, we want to set the shader property to the shader that we just created. So if you use the preload and find our mirror shader, and then we want to assign this material to our mesh. And since we just renamed it to mirror mesh, we can say mirror mesh. And it's mesh instance 3D, and we just call it mirror mesh. So let's grab that mesh and set surface override material at slot 0, and we are going to set it to the mirror material that we just created. And last thing to do is to send over that picture from our viewport into the shader. So let's grab our material and set shader parameter, and we called it mirror texture, and we pass in the texture from our viewport. So viewport get texture. So now our shader has information about the image that was captured by our camera. So if you now go back to our main scene and assign our player and press play, we get nothing. So let's fix this. Let's just open our texture rect and set the expand mode to ignore size. And now if we press play, we can see the mirror is showing the picture that we captured through the camera. That's also shown in the upper left corner. It doesn't quite look like a mirror just yet, but it's a step in the right direction. So let's now position our camera to be on the opposite side of the mirror. So first we're gonna grab our player camera and we're gonna convert it to local space. So if we call to local, we can pass in a global position and it's gonna convert it to local space. So player camera dot global position. And then we can say that the mirror position is gonna be a vector 3. And we can copy the X, Y, and then flip the Z. And now we have a position where we keep the same height and sideways offsets, but we are on the opposite side of the mirror. And now all we have to do is take our mirror's camera and say that its global position is equal to the mirror position. But remember, we have to convert it back to global space. So we call to global, and it does the inverse of what the to local does. So let's just pass in our local mirror position, and now our camera should be positioned correctly. Now back in our game here, I'm just gonna change our texture rect's stretch mode to keep aspect. That way it's not gonna be a square on the screen, it's gonna be the actual aspect of our main viewport. So if I press play now, we can see there's a clearer image here. However, it's not showing anything just yet. And the reason for that is, even though our positioning is now correct, the rotation is not. So it's pointing away from us right now. But if I flip it over to this side, you can see that the image starts to appear and we can see our character. So what we have to do now is rotate our mirror's camera to match our player's camera rotation in a way that it's also affected for the mirror's reflection. So let's go back to the drawing board. Let's say we have our mirror like so, and this is the normal vector. This is the vector pointing away from our mirror's surface. And then we have a vector coming in and then being reflected like so. So how do we get to our reflected vector from our initial vector? Let's call this V and then VR or reflected. We can start by doing a dot product between vector and the normal vector. And what that does is tell us how much of our original vector is lying on the axis of our normal vector. So we're basically breaking our vector into components which are perpendicular and in line with the normal axis. And then if we multiply that with the normal vector itself, we'll get a vector of that component. So let's draw it from the origin like so. And then I want you to notice something. Let's translate this original vector so it starts from the origin. And then if you take our green vector and subtract it from our original vector, not once, but twice, we actually end up with a reflected vector. And that's exactly what we need. So let's see what we did. So we took our initial vector and then 2 times subtracted the green vector. So this is our formula for the reflected vector. And luckily for us, Godot already has a function that will do this for us. So we don't have to type all of this. This is just for learning purposes. Alright, so let's construct our reflected basis. So first let's define the mirror normal, which is gonna be the global basis.z or negative z, and let's just normalize it so it's a unit vector. And then we want to get a hold of our player basis. We have our player already, and we can just grab the global basis from it. So now we want to construct a reflected basis, and there is a nice function on basis called looking at. And this constructor will take in a target vector and an up vector. And target is going to be the direction we want to look at, and then up is used to kind of orient the roll correctly. So we only need to reflect our player's camera forward vector and the up vector. So let's declare a reflected forward vector, and we can say player basis dot z, and it's a negative z, that's our forward looking direction. And then we can call bounce, and this is the inbuilt function that will reflect a vector around a normal. So we just pass in the mirror normal in it, and then we do the same for reflected up, player basis dot y, bounce, mirror normal. And then we can pass these two to the looking at function. So reflected forward is where we're going to be looking at, and then the reflected up is going to be used to match the third axis as well. So now that we have our reflected basis, we can set our camera global basis to the reflected basis. So if we start the game now, we will see that we have something that sort of looks like a mirror, but it's inverted. So we can easily fix this by going back to our shader editor and flipping the y's of our UV map. Let's just declare a new vec2 called UVs, or just UV is fine. And it's gonna be vec2, and we're gonna use UVx, but we're gonna flip the UVy by doing 1 minus UV.y. And then instead of using the UVs directly, we're gonna use our own UV variable here. And if you press play now, we have something that almost looks like a mirror. And the problem here is that we are still using the plane's UVs. That means it's always kind of projected from that surface out, and that just looks weird. What we want to do instead is have this image always oriented towards us. And the way to do that is to use the screen UVs instead. So if you go back to our shader editor, you can use screen UVx and screen UVy. And if we press play now, we have, well, again, things are inverted, but it's looking very funky right now. Let's remove this Y inversion that we did and see what we get. Okay, this definitely looks better. However, the problem is that the X seems to be flipped now. So let's go back again and flip the X's instead. And now when we go back to our game, we have a mirror with a perfect reflection. Now I will hide this camera's mesh now because it's a bit confusing. So one of the problems here is that the camera that's capturing the reflection is coming from behind the mirror, which means that everything behind the mirror will also be shown in its reflection. So let's drag this box and put it behind the mirror. It almost looks like this box is floating in the air, but it's actually the reflection on the mirror. It doesn't exist. However, it's being captured by the camera from behind there. So we need a way to hide this box somehow. And the easiest way to do this is to use render layers. So if I open this box and select its mesh, I can say that it only exists on layer 20. And then if you go to our mirror's camera, on the Cull mask, we want to hide layer 20. And if I do that, now that box doesn't exist in the reflection anymore. Of course, I can see it normally with my own player's camera because we haven't touched the masks there at all. So that's one way to get rid of the unwanted reflections from behind the mirror. Now, one thing that we could do is insert some sort of a quality slider. What I mean by that is right now our mirror is capturing the screen at the viewport's resolution. What we can do instead is declare a variable. We can export range in fact, and let's say it goes from 20 to 100. You can call it quality and set it to 100 by default. And then you can multiply this by quality times 0.01. And now if you go back to our mirror and we select it, we could set our quality to say 20, which is not great. However, if you go to 50 or 60%, you'll see that the reflections are now still quite sharp, and we're only using about 50% of the resources. Now, another improvement that you could add is imagine you are in a room, and when you're outside of it, you don't see the mirror, and yet the mirror is still rendering everything. It's using resources for nothing. So what you could do is have a function called setActive, which would get a param called active. It could be a boolean, and what it would do is disable the rendering from the viewport. So it would be viewport.render target update mode, and you could say update mode always if active, else update disabled. You could also set process to active. So then when you walk outside of the room, you could say active is false. So the viewport rendering would be disabled, and the whole process function for calculating the rotation and positions would be disabled, and vice versa when you get closer to the mirror. So I hope this gives you a good basis for when you go around creating your own mirrors. And as always, if you liked what you saw, learned something new, please subscribe, and I'll see you in the next one.